Good evening.
Good evening.
I'm Yovna Salin, a second-year student of Bachelor's of Design in Humanizing Technology, and your host for the evening. Today at Design Perspectives Speaker Series, we're diving into the world of anthropocentric design. Our speaker for today is here to introduce that to us. On behalf of NMIMS School of Design, I extend a warm welcome to Professor Prasad Boradkar, along with our director, Professor Manisha Fatke, faculty and students. Since this is a virtual event, we request you to mute your microphones and turn off your videos. However, questions are most welcome. Please type your questions in the chat section. We will be taking them at the end. I'd urge you to explore more through them. Before we proceed, a little bit about our speaker. Professor Prasad Boradkar is currently leading efforts in interaction design, user interface, and user experience for 2 projects in Google's Advanced Technology and Projects Group in Mountain View, California. He is also a Professor Emeritus in Industrial Design at Arizona State University in Tempe. Prior to joining ASU, he was a professor in industrial design and also served as co-director for the Biomimicry Center and the Innovation Space Program. He is the author of Designing Things, A Critical Introduction to the Culture of Objects, and co-editor of Encountering Things, Design and Theories of Things. We look forward to an engaging session, Professor Prasad Boradkar. The virtual stage is yours.
Great, thank you. Thank you to everyone at NMIMS, especially Manisha for inviting me to speak today. And I recognize just realized it's Friday morning here, but it's Friday evening, 7 p.m. for you all. So it takes a lot of dedication to be able to attend a lecture at this time rather than being out and about. So thank you to all of you who are attending. I'll share my screen and go through the presentation. All right, I hope everyone can see my screen. Am I good to go? Is everyone able to see the screen?
Yes, your screen is visible.
Excellent. All right, great. Okay, so as it was mentioned earlier on in the introduction, the title of the talk is Beyond Anthropocentric Design. And I'll get into this a bit more detail as we go through the presentation, but I'll quickly mention that there are 2 roles that I'm playing currently. One, as was mentioned in introduction, I serve as user research and sustainability lead at Google in Mountain View, but I also hold a Professor Emeritus position at ASU. Unfortunately, I can't talk too much about my work at Google, and therefore I'll focus this presentation and this talk on the work that I did prior to joining Google, which is about 4 years ago, while I was still at ASU. So I'll give a brief introduction to the programs that I was running at Arizona State University, talk about some of the work that we did in thinking about going beyond anthropocentric design, show some examples of some of the student work, and then we can get into a discussion afterwards. So thank you again to all of you for joining. So I'll start really quickly by talking about Arizona State University, ASU, which is in the state of Arizona in the US, in the southwestern US. It's one of the largest universities in the US. And interestingly, the image that you see in the front here is one of the last buildings designed by Frank Lloyd Wright. It was strangely a building designed for Baghdad in Iraq, and the building was built on ASU's campus after Frank Lloyd Wright died. But it's a large university with a variety of over 200 undergraduate programs, lots of graduate degrees. So I spent about almost 20 years at ASU. And while I was at ASU, I was essentially a professor in the design school. I was the chair of the department for a while, and it goes back to my background in industrial design from IDC in Hawaii. One of the things that I did while I was at ASU was, along with some other faculty members, we started a program called Innovation Space. And what you see here in this quick sort of pan across the studio is students working in teams. And our idea for Innovation Space was to put together a program that looks at innovation from the perspective of what we referred to at that time as integrated innovation, which essentially asked 4 key questions. So as you start designing anything, it could be a product, it could be a building, could be a landscape, some graphics, an app, whatever it might be. Let's start by asking 4 key questions. What is valuable to people, or is what we are designing bringing some value into people's lives? That's one question. The second question is it possible, is it feasible through engineering? So do we have the right kind of materials, manufacturing technologies, et cetera, if it's a physical product, or the digital technologies to make something happen? So do we have the engineering means of making this feasible, bringing it out into the world? The third question is it desirable for the corporation? Is it something that benefits the company that is investing time, effort, human resources, et cetera, into making this out into the world? And the last question, which sadly is asked the least, is what is good for society and what is good for the environment? And so what we were trying to do at ASU was to follow this model of innovation, but that we refer to as integrated innovation, with the notion that as you look at this sort of Venn diagram, true innovation or truly integrated innovation happens in the center. So when you are able to, through the work that you do, answer or try to bring some sense of an answer to these 4 questions, you may have a new innovation that works for people, makes sense for the environment, works for the corporation, but also is feasible. So that was the goal of this program. And in order to do this, we put together teams of students from different disciplines. So this is one of my extremely happy teams from a few years ago. And the students worked in teams over a year. So these were undergraduate students. They were working on their bachelor's degrees. They were in the last year of their program, working on what's often referred to as a senior project or capstone project. And that capstone project over 2 semesters, over 1 year, guided them through this process of finding a problem, doing research, being able to come up with tons of ideas, et cetera, moving to a final solution. But the reason we had this specific makeup of disciplines, business, industrial design, sustainability, graphic design or visual communication design, and engineering, is because we thought in order to answer those 4 questions that we looked at in our model of integrated innovation, no one discipline can do it alone. You have to, especially when the problems that we are solving or trying to solve are extremely complex, you need people from a variety of disciplines working together. So this notion of transdisciplinary problem solving was fundamental to the program of innovation space. And these students, as they were working together, for example, as the industrial design student was designing a new product and building models, et cetera, making renderings, at the same time, the business student was coming up with a business plan. How would you commercialize a product like this? At the same time, the graphic design student was thinking about how do you brand this product? Do you need to build a website? Is there an app that goes with it? So that student would design that. The engineering student would look at materials, manufacturing technologies, and build a functional prototype. And the sustainability student would come up with a sustainability strategy, life cycle assessment, et cetera, for the product. So in a nutshell, what the students did as a team were not only learn from each other, but also contribute towards a more holistic way of solving problems and come up with a more comprehensive way of answering the 4 questions that we asked in the previous slide. So that was the goal of innovation space. And I'll get into more details about some of the processes that we follow to come up with designs that go beyond purely anthropocentrism. The other thing that I was involved in while I was still at ASU, at Arizona State University, was I was the co-director of something called the Biomimicry Center. And this was something that we launched along with a group called the Biomimicry 3.8 group, which was started by an amazing woman, Janine Benyas, and I'll talk about her in just a few minutes. So the center was started at ASU a few years ago, and we had a research program, an educational program, and the center offered one of the first 2-year master's degrees completely online in biomimicry, and the degree is still ongoing. So I was actively involved in running this center. And the goal of this center was essentially to look at how can we do research and develop educational programs to advance nature-inspired solutions. And again, this is where I'll start talking about biomimicry. The idea is that nature has been evolving, adapting to local conditions. And if we look at how these adaptations and evolutions occur, can we learn from that? And can we use that knowledge and that inspiration to come up with solutions to our problems today? And so that was the goal of the Biomimicry Center at Arizona State University. And so that's something I've been involved with the past several years. And as was mentioned in the introduction, my current position, I'm at Google, and there's a group called ATAP, which stands for Advanced Technology and Projects. And I'm on one of the teams in ATAP, and my role is to do user research as well as sustainability for this team and for the project that I'm working on. Now, I'll quickly mention one thing about ATAP. When we think about how research is done, very often, and this was a model that was talked about after World War II, which you have basic science or fundamental research at one end, and then you have technological innovation at the other end. So it was thought of as a continuum with these two things at the two ends of the spectrum. And what Donald Stokes talked about was you can't really imagine those two things as two ends of the spectrum. Instead, you have things happening in conjunction with each other. And so he came up with this model where you ask two sort of questions. On the sort of y-axis, you see, is this a quest for fundamental understanding? And on the x-axis, considerations of use. So the folks you have here on this diagram, on the top right corner is Louis Pasteur, who was an expert in microbiology, did pasteurization, vaccines, etc. So Louis Pasteur's work is referred to as use-inspired, but also is fundamental research. So he did fundamental research, but also came up with applications that were beneficial to humanity. On the left, you see Niels Bohr, who did pure basic research in theoretical physics. And at the bottom right is Thomas Edison, who came up with the light bulb, phonograph, etc., which were purely applied research. So this is the kind of one mechanism by which you can categorize how research is done. And what we do at Google ATAP is in the top right corner. So that's referred to as Pasteur's quadrant. And so the work that we do in Google ATAP is focused on that top right corner, which is doing research that solves an important problem for people, for the environment, but also is something that is technologically advanced. And that's the goal of this group within Google. All right, so we can now sort of jump into talking about sort of what is anthropocentric design and what can we do to move beyond it. So we, as you all know, as designers, you all know that we face a series of really complex, critical challenges of climate change, global warming, etc., in the world today. And there are multiple reasons for why this is happening, but we can talk about a couple of things. One is the problem of resources and waste. So if you think about it, we have only one planet, a finite planet, at least so far, one habitable finite planet with a limited number of resources, whether it is water or it's minerals, whatever it might be, we have one finite planet. And we are using resources faster than ever and more resources than we ever have. At the same time, we are also generating enormous amounts of waste. And what happens to this waste? We can't really wish it away. It lingers. It stays in landfills on the planet. It ends up in oceans. And so what we've done is we are really rapidly using resources. And at the same time, we are generating lots of waste without knowing how to deal with this amount of waste that we're generating. And what are the reasons for this stuff? I mean, there are multiple reasons for why we are in the position that we are in today. Clearly, there are political reasons. When a government does not refuses to recognize that there is a climate problem and refuses to create policies or put monies into addressing these problems, you have political issues and political blocks to addressing problems of climate change. There are economic problems where in some cases it might be expensive to focus on environmentally friendly technologies and solutions. So there could be economic issues. There could be issues of education, there could be cultural issues, individual issues, institutional issues. So there's tons of reasons why we are in the situation that we're in today, which is we have been using resources very rapidly, and we are generating tons of waste. But we could also think about this as a problem of design, right? So what can we do by design? One, to understand the problem that we are facing today, and then to come up with solutions as well. So as we all know, one of the predominant paradigms in doing design work today is human-centered design, right? So this is what you see in this image is human-centered design, the toolkit that was developed by the design firm IDEO. And human-centered design essentially focuses on the notion that we can design products that are focused on addressing the needs of people. As we all know, that the planet is now has more people than we can support. The population of the planet is close to 8 billion, 7.9 billion or so. And so this notion of designing for people does make sense, because we do need to address the needs of all these 8 billion people on the planet. And this goes back several years. So this is a book written by Henry Dreyfuss called Designing for People. This is in the early 1950s, actually, 1953. And Dreyfuss talked about this notion that when we design something, you might know of Henry Dreyfuss. He's often referred to as the father of human factors and ergonomics. We sort of one of the pioneers in making this a key part of the discipline of ergonomics and its application in industrial design, especially. So Dreyfuss talked about this notion that when we design something, it is actually used by people. People, if you're designing a chair, people sit on it. If you're designing a handheld device, people are holding it. So thinking about the human body and the relationship of the human body to this object is really important when you think of design. So there's a really interesting and important idea that you take into account when you design for people. And so what that translates into, not just from a human factors or ergonomics perspective, but a broader perspective of how we do design, is you look at people's needs, you look them in the context of where they live or work, and then you come up with innovations, come up with ideas that address those needs in the context of people's lives. And that makes perfect sense. It's a valuable and an important approach. And what human-centered design did, user-centered design, human-centered design, what it did was it addressed what used to be, and what's often happens, is this notion of technologically driven design. So very often companies do this. They have a new technology, it could be a new material, could be a new product of some kind, could be a new chip, could be any new technology that is developed. And they see potential in converting that into some sort of a product, and it goes out into the world. And while this is reducing these days, because human-centered design as an approach has been adopted by companies all over the world, it used to be, and it still continues to be, an issue. People will come up with innovations that are purely driven by a new technology. They'll create a product out of it, throw it out into the world, and it may or may not be successful. And many companies pop up and disappear simply because they didn't do enough research and understanding. Does it actually solve a problem? Is there actually a need that this technological innovation addresses? So one of the advantages of human-centered design is that it doesn't fall into the trap of doing purely technologically driven design. The other thing that human-centered design does, which is admirable, is that it goes beyond purely market-driven design. So just because there is a gap in the market, or just because you want to create another product that is slightly different, it is faster, sexier, better looking than something else, doesn't mean you have to put it out into the world. So human-centered design goes beyond market-driven design and technologically driven design. So it has advantages, actually does something good towards people. But where does it fail? Should we ask the question, is human-centered design actually a good approach? Where is it good? Where does it fail? And let's look at some examples of where some of this idea of designing for human need could be an issue. So this is a product that all of us know. It's the Swiss Army knife, right? It's one of the early versions of the Swiss Army knife. As this product evolved over time, more things were added to it. So you have not only a knife and maybe a screwdriver, but a couple of things. You have a corkscrew and you have a bottle opener and a nail file, etc. That's been added. And then you add some more things to it. You know, you're in the digital world now. So you have to add a USB, a pen drive to it, and a laser pointer in addition to a keychain, etc. So the product starts getting more and more complex till it gets to a stage where I can't imagine anyone's pocket that this product would fit into. It actually is a product on the market from a company called Wenger. And it actually has taken this notion of a Swiss Army knife from a portable device to something that's ridiculously large. So you may have heard the term feature creep. Because we can design something, do we keep designing? Because we can add a feature, do we keep adding features? So it's an interesting question that we should ask ourselves. Is there a limit to human need? Is there a limit to feature additions? And where do we draw that line? And we can sort of take a look at need-centered design and critique it a bit more. So, for example, and this is very typical here in the US, you can go into one of these stores where they sell kitchen appliances like Williams-Sonoma, etc. And you can buy, for example, and I'll show several photographs, you can buy an avocado masher, or you can buy a special implement which is an apple slicer, or you could buy an apple peeler that just peels the skin of the apple, or an apple corer that takes the kind of centerpiece out, or a strawberry corer, a strawberry slicer, a banana slicer, a special device for removing seeds from a pepper, a jalapeno pepper or any kind of a pepper, something that removes a corn husker, removes the ears of a corn, a cherry pitter, a mango slicer, a peach slicer. So you can use all these devices designed specifically for specific fruits, or you could use this one product. You could use a knife, right? So this begs the question, when we create such a large number of variegated needs that I need a specific device for a specific application, are we going overboard? Are we flooding this world with a host of products that perhaps are not needed? Perhaps this knife will do. Now, I can imagine situations where you could say, well, in certain cases, there might be someone with disability, someone who may have limited mobility. In that case, maybe the product does make sense. So there could be situations where these specific products designed for very specific applications might have meaning, but in some cases, it does raise a question, are we designing too many individual products for very specific individual needs when a more multifunctional device might do the trick? So it's a good question to sort of keep in mind as we design. So can we then go beyond this notion of just human needs? Can we go beyond human-centered or anthropocentric, because anthro refers to humans? Can we go beyond anthropocentric design? Do we need to think about going beyond anthropocentric design? So one way to think about it is thinking of all the species on the planet. So you can say, okay, so the fundamental goal of human-centered design is designed by and for people. However, if you think about it, are we the only species on the planet? And for example, do we know how many species exist on this planet? We actually don't. There are some scientists who have done some modeling and they try to look at patterns in ecosystems and try to figure out how many species might be on this planet. And the estimates are wild. Some people say it is anywhere between 5 million to 1 trillion. Some latest numbers peg it at about 8.7 million, still shy of the number of individuals on the planet. And as we think about this, as we sort of zoom into this tree of life, we see the amazing Mr. Charles Darwin representing Homo sapiens sapiens, the one species that we represent. So if you think about it, if we are one of millions of species, or maybe trillion, who knows? So if we agree that there are 8.7 million species on the planet, we have actually, through taxonomical work, only identified, cataloged, and done research on 1.2 million. Most of those are insects. So not only are there millions of species that we share this planet with, but most of them we don't know much about, especially marine species. So that then begs the question, if we share this planet, this one finite resource planet with 8.7 million species, and we are only one of those millions of species. Does it make sense for our design to focus only on one species, that's us humans? And does that end up making design really myopic, that we are only thinking of one species on this planet when we share this planet with so many species? And how do we share? How do we think of our place in this planet? In most cases, we are the apex predator, right? So we sit at the top of this chain, we imagine, and if you notice, it's man, the woman is the second in this chain. So we often men think of us as a sort of patriarchal, male-dominated society, where we are at the apex predators on this planet. Can we think of a different model? Can we imagine ourselves as one in a network of species where we are not necessarily the apex predator? We don't think of ourselves as the smartest and the most technologically advanced and the most resourceful species on the planet, but we are one of many species that we share the planet with, and we are not the apex predator. We can think of our place in these multiple ecosystems. We bring in a little humility in our thinking and in our place on the planet, and we try to think, can we go beyond human-centered thinking? Can we go beyond human-centered design? Is there something we can learn from other species? And what would that be? So one of the things that we perhaps could do is we reimagine our relationship to nature. We are a part of nature, right? So we are, if we think of ourselves as human species that evolved over billions of years, we are a part of nature. But we often think of ourselves as different. When we think of resources, when we think of, for example, when we think of mining resources, there's often this conversation about conquering nature, that we are able to conquer nature and get resources from it. Perhaps we should rethink that position. Perhaps we should think of ourselves as a part of nature, and imagine how, if we reimagine our relationship, how differently would we be in dealing with the resources that are available to us, these finite resources. So taking a quick look at the Sonoran Desert in Arizona, where I used to live. If you look at this environment, if this look at this location, it's primarily a desert. It's a different kind of a desert. It's not the sort of sandy deserts that we might imagine typically of sub-Saharan Africa or perhaps of Rajasthan, but it's a desert with a different sort of a set of ecosystems. If you look at how development has happened or how we humans have built in the desert, so what you see on the right is the desert itself. You see sparse vegetation, and you see the landscape on stretching out in between the sparse vegetation. And on the left, you see human development. So this is houses that we build. Now, it is shocking to see the difference between them. So essentially what we've done in the way we've built in the desert is you've created a very, very clear, I mean, it's so obvious, right, in this aerial photograph. There's a very clear division between how we live and how the rest of the species live. So the Sonoran Desert is not necessarily a biodiversity hotspot, but it has some remarkable features. Apparently, they say that the modern dog which came from wolves could have potentially emerged from the Sonoran deserts. Anyway, so we see this very stark difference between the way we build in relation to what the desert is like. Do we have to cut ourselves off so starkly from nature? Can we reimagine how we build, keeping in account and taking into account how the local systems and the local ecosystem and the local conditions are, and build in conjunction with those instead of away from them? And so another photograph from Arizona, this is in southwestern Arizona, a place called Bisbee, where there used to be lots of mining, open pit mining. So this is a photograph of an abandoned mine. What happens when we do open pit mining? So we essentially completely erode the surface. We kill all vegetation. We use extremely toxic chemicals. This used to be a copper mine. Extremely toxic chemicals to extract copper from the environment, from the ore. And in this process, you can see that the clearing of the land of all vegetation, the using of toxic chemicals leaves this awful sludge that you see at the bottom, and the landscape becomes completely inhabitable to plants and animals. Nothing can survive in this because it's really toxic environment. So what we've done is, in taking out these resources like metals and other minerals from the earth, we actually destroy everything that's there. We destroy all life that's living or used to live in that region. Can we reimagine this? Like, instead of taking minerals out of this earth, can we take ideas? And that was a question that this woman asked. So this woman is Janine Benyus. She wrote a book, published a book in the 1990s called Biomimicry: Innovation Inspired by Nature. And the way she defines biomimicry is it's the conscious emulation of what she refers to as nature's genius. And then she asks this question. So instead of mining resources from nature, can we mine nature for ideas? Over 3 billion years of evolution, more than 3 billion years, maybe 4 billion years. Species have evolved, species have adapted, species have gone extinct, new species have emerged, and that has all happened in reaction, relation, and adaptation to the conditions in which these organisms find themselves. And so can we learn from evolution? Can we learn from how things have changed? Can we learn from how nature solves problems? And that's essentially the goal of Janine Benyus's book. And so when we started the Biomimicry Center at Arizona State University, we worked very closely with Janine, her group, in coming up with the educational program, in coming up with research programs, et cetera, at the university. So let's look at some examples, and I'll show some really common examples. So this plant that you see here with the flowers and the seeds, this is the burdock plant. If you look at those green seed pods, you'll see that there's little hooks at the end of these spines. And what happens, and that when animals walk by these burdock seeds attach themselves to these animals, as in case of this really handsome goat, happened to walk by this burdock plant, and these seeds got stuck to its hair. We've all seen this very commonly all over India. These plants are really prolific all over the world, actually. So this is a seed dispersal mechanism for the plant. In order to propagate, it creates these seeds that have little hooks on them. They're attached to long hair of cattle and other animals. The animals move, the seeds fall off somewhere else, and the plant propagates. So this idea has led to what's often referred to as the hook and loop system of attachment that a Swiss scientist, Giorgio Mestral, came up with as he was taking his dog out for a walk. And this is often referred to as Velcro. So what we know as Velcro today was inspired by something in nature. So in a way, it is a design that has come from watching and observing something in nature. However, one of our goals at Arizona State University and the Biomimicry Center was to question that in creating Velcro, have we truly copied nature? And we think, no, we have not. And the reason for that is, if you think about what Velcro is made of, so the materials that are used in making of Velcro, it's often PVC or polyethylene. These are polymers that essentially could end up in a landfill and could last for thousands of years, if not longer. What happens with the burdock seed? So when the seed disperses itself, it could fall on the ground. It maybe gets cracked open by the animal's hoof. It opens up, the seed goes into the soil, a new plant emerges, the seed pod disintegrates and disappears into the world, right? So there's no waste left behind. There's no toxic waste left behind. What happens to our polymers? What happens to things like PVC and ABS and polyethylene, PE, HDPE, LDPE, etc.? We all know that these things end up very often in the oceans. And the problem of microplastics in oceans has been a huge problem, a huge issue. And I recently saw that for the first time ever, microplastics have been found in human blood. So these plastics travel, they do not completely disintegrate. They break apart into smaller and smaller particles. They end up being ingested by marine birds, by marine animals. Plastic bags look like jellyfish, and they're consumed by seafaring turtles. So unless we create something that is truly biodegradable, that disappears in the world, like the seed pod does, we haven't truly copied nature. We've copied nature to a certain extent in the functionality of Velcro, but not Velcro's existence. And so what we were trying to do at ASU is to use biomimicry for sustainable solutions, not just for interesting solutions, but more sustainable solutions. And I'll show a couple of examples that the students were working on, and some of them are still working on these ideas. So this is a project that's referred to as a bat brolly. And it was inspired, the designer on this project was a biology student, a PhD student in biology, Clint, who looked at a problem that he faced of umbrellas. If you use an umbrella and a heavy gust of wind happens to come sideways, your umbrella turns inside out. Apparently, these bat species, one of the bat species has a certain sort of design of its wings that prevents that from happening to the bat. So if bat is flying and a gust of wind comes from the side, it doesn't upturn, it doesn't fall down to the ground. And there's a certain reason for that. These offset joint angles, the bones of the wings are hollow. They also have a sort of an oval shape instead of a circular shape. So they're very tough in one, if you bend it in one direction, very tough, but more flexible in another direction. They get smaller as you go towards the edges. So Clint designed a new sort of an umbrella, they refer to as a bat brolly, that was inspired by the wings of the bat. And we're still building prototypes, so we don't know if it actually will work the way he imagines it, but it hopefully could. Another example, this is inspired by the Namib beetle that is found in Western Africa. This beetle does a very interesting thing of water collection. So every morning a fog rolls in its body up in the air, it collects the fog, it drinks water. The way it does this, the diagram that you see in the middle is sort of a cross-section of the beetle's back. So it has these bumps that you can see in the image on the left on its body. The convex surfaces are hydrophilic surfaces, so they actually attract little drops of water. The concave surfaces are hydrophobic, so they repel water. So as the beetle is sitting in the fog, the small water droplets attach themselves to the hydrophilic surfaces, and as the water droplet gets larger and larger, back and mouth. So that's how it drinks water. And the image you see on the right is something that students collection device, where it has panels that unfold, which have this sort of structure, hydrophilic hydrophobic surfaces that collect water from for arid environments. One other example, this is humpback whale, and what you see in this photograph is if you look at the white pectoral fin, you see these little tubercles, these really bumpy regions on the pectoral fin, and that apparently has several really interesting purposes. And this is a wind turbine, which is inspired by the shape of the tubercles on humpback whale's pectoral fin. What they've discovered is that if you create this sort of a surface on the leading edge of the fin, it prevents stalling, which can happen very often in wind turbines. It creates more efficient flow. Even if the wind speed is not too high, it can still rotate and generate certain amount of energy. It's been used in fan blades. And I think, I'm not completely sure, but I think I've seen this fan or a very similar fan at the airport in Pune. And the green section that you see, the bumpy region that you see, is inspired by the tubercles of the whale. So, so what we've seen so far in terms of examples of biomimicry essentially are from specific organisms. You can also do biomimicry at a larger stage, at the scale of ecosystems. So what you see in this image is an example of industrial symbiosis. And this is in a city called Kalundborg in Denmark. And what this is a group of companies that got together to share waste. So what this means is that one company might have extra water, which is a byproduct of its processes, that's given to another company that needs water. Some company might have extra materials that are part of its byproduct that goes to another company. And this sort of complex system of shared resources. So for example, you can see in the photograph, there's gypsum that is a part of a byproduct of a company that goes to another company that makes sheetrock, which is used in construction. So by sharing these resources, what ends up happening is that the overall waste output from this industrial symbiotic system is a lot less than the waste from individual companies. So when you create this sort of industrial symbiosis, when you see symbiosis in nature all the time, in ecosystems where resources are shared, you can reduce your overall waste footprint. And that's what's happening. So biomimicry can happen at an ecosystem scale as well. So in terms of the process, like what sort of process can we use, and what process can be taught in terms of being able to do biomimicry? And so let's look at this process. So this is an example of a process from the biomimicry 3.8 group. You start by defining the problem. So I want to create a system that creates more efficient wind turbine blades, for instance. You biologize that problem. So you ask the question, how would nature do this? Then you try and discover examples like the whale to see if there are examples in nature that have tried to solve that problem. You extract and abstract the principles. How does nature do this? What are the mechanisms that nature uses? What truly is a function? And you try to emulate it, try to copy it in ways that you can for your design solution. Then you evaluate it. And when you go through the spiral, you may have a truly biomimetic solution. And this is the process that can be followed. And so what we were doing at the university, and as you recall, the class that I was teaching had students from 5 different disciplines. So can we use biomimicry for all disciplines? And the answer is yes. The way you think of the problem, if you are able to rephrase it in biological terms, you can come up with something in nature that has in some way solved that problem before. So for example, if you look at 4 different disciplines: business, engineering, industrial design, visual communication design. If you have a list of functions, I need my product to fold, to conserve energy, to be easy to clean, to be small, to be compact, et cetera, et cetera. You have a series of functions that you need your product to solve. You can reframe those questions in biological terms. Then you search for biological inspirations, and you can do it in one of 2 ways. Either you look at an organism like a whale or some fish or the beetle or the bat, etc., or you look at principles in life, and I'll talk about that in just a bit. And then you come up with your solution. So this becomes sort of the strategy or the process for doing biological inspired design. So the Biomimicry Institute and Biomimicry 3.8, that group, they looked at several organisms and several ecosystems, and they tried to come up with principles. Like, are there certain principles in nature that are followed by most organisms, or if not all organisms? And they came up with a series of 8 or 10 principles, and these are some of them. For example, if you see the one on the top, it's adapt to changing conditions. So environments always change, and organisms adapt to change, to respond to those changing environments. The next one that you see on the right is be locally attuned and responsive. So be aware of what's happening in that local environment. The third one on the right is use life-friendly chemistry, so water-based chemistry, not to use toxic chemicals or solvents, but to try and use chemistry that is conducive to life. And there's more around the circle. But if you look at the center, it says life creates conditions conducive to life. So in everything that we design, if we think of this, we don't destroy life, but we create more life. So what happens when you create something out of plastic, a plastic bag, for example, and that plastic, that LDPE, low density polyethylene bag, ends up in the ocean, and an organism eats it, that organism eventually dies. So what we've done is we've not created conditions that are conducive to life. We've done exactly the opposite. So these are the guiding principles of life. Can we then draw some design ideas from that, or design principles? So what you see in the gray area, just outside the central hexagon, are these principles. So for example, if you look at the bottom in the center, be resource efficient. That's one of the principles that you see in nature. What does that mean if you're doing design work? Use low energy processes, use multifunctional design, recycle materials, fit form to function. So you can see that by looking at how nature has evolved, adapted, and solve problems, we can come up with strategies that we can use as designers, as business people, as engineers, etc. And so just a quick example of another product that students did. This is an aromatherapy product. And the interesting thing about this, if you look at the box, the packaging, the students realized that packaging constitutes for a significant amount of waste in the landfill. And packaging is interesting. You need packaging because you need to ship something from the factory to the warehouse to the shop to the consumer's house. But then once it completes that journey, in most cases, not always, it's thrown out, right? And if you use paper, if you use thermocol or expanded polystyrene, if you've used plastic film, all that ends up in the landfill, unless there's recycling mechanisms to take it back. So they thought, can we reimagine that packaging? So the packaging in this case is, if you can see, it's made of jute and it's starched. So while it's in a box, it sort of maintains the shape of the box because of the starch. You take the box home, you wash it, the starch washes out and becomes a carry bag. So one way of thinking of multifunctional design, recycling materials, reusing them as a form of doing biological inspired design. So students and faculty at ASU came up with a series of these principles organized in 3 different categories: efficiency, resilience, and building relationships. And this is what nature does really well. It's efficient. It's not optimized, it's efficient. So use waste as raw material. The photograph that you see in the top left, the small image, is that of a dung beetle. Dung beetles are amazing. Imagine sub-Saharan Africa, imagine a herd of elephants goes through a certain patch of land. They drop kilos, tons of dung. What happens? Very quickly, hundreds, if not thousands of dung beetles show up. They roll the dung into little balls. They roll those balls into the nest. The lady dung beetle lays her eggs in it. And as soon as the babies hatch, they have this amazing food right there for them to eat. Tasty. So this is an example of using waste as raw material. So you can see several examples organized by these 10 principles, or 12 principles, and 3 categories. So we can learn from nature in terms of these principles and apply them as design guides. But where do we search for these examples? The Biomimicry Institute has put together this amazing resource called asknature.org. And I'll kind of click on this for a second. We can take a look at the at this website. I'm not sure if you can see my screen. So I'm going to stop sharing and share again, so you can see Ask Nature. All right, so I hope you can see my screen now. So this is the website called asknature.org, and it's an amazing resource because it asks these sort of biological questions. How does nature protect us from pathogens? How does nature create community? How does nature coordinate? How does nature regulate climate, regulate temperature? So depending upon what kind of problem you might be solving, you could go to asknature.org and you could try to find strategies in nature, biological strategies that have solved this problem. So for example, if I'll go to just one quick thing and look at some examples, you'll see tons of examples. Faculty can get examples from here. Students can see examples. There are lots of biomimicry stories. We talked about the Velcro story that you see here, the lotus leaf for cleanability. It's an interesting example of a robot that's inspired by the elephant trunk. There's a really interesting company called Festo in Germany that has created these robotic arms that are inspired by the trunk of an elephant. So, I mean, as you spend some time on this website, you'll see a series of really remarkable examples of how, by looking at the kinds of diversity in nature, you can learn from this and you can apply it to solve human problems. So I'll go back to the presentation. So how do we apply these to different disciplines? So like I mentioned in the class, we had industrial design, visual communication design, business, engineering, etc. Let's take examples. So what you see on the top is the process, the biomimicry process. Function, list your function, reframe them as a question, look at an organism from Ask Nature, see if there's a life principles that you can look at, and then find your potential solution. So here in this case, if you're an industrial designer, your problem or your function that you're trying to solve for is you want to design something that is easy to clean without using toxic chemicals, right? We have lots of chemicals that we use for cleaning, but you don't want to use toxic chemicals. What would that be? So reframe the question. How do organisms keep their surfaces clean? Skins, leaves, petals, etc., free of dirt. So lotus leaf has the right kinds of surface characteristics at the nanoscale and uses water. So the water droplets don't really go into the leaf, but they sort of roll off the surface and they carry dirt away with it. So you could use that, and that actually is a paint that has been produced by a company that does that. So as the building is painted with that color, when it rains, it sort of cleans off automatically. You can use that for business solutions. You want, as a business person, you're coming up with a business plan. You want to reduce waste in the system to create cost savings. You want to lean manufacturing process. How do you reduce waste? So you ask the question, how do organisms manage their resources, raw materials and waste? So all waste from one organism, for example, a tree sheds leaves every season. That's converted into raw material for another. It becomes fertilizer. It becomes, in a sense, it becomes life-giving for the next organism. So that's one example of sort of a lean process. If you're a visual communication designer, you want to create communication messages that send the benefit of a solution, that communicate the benefits of a solution to specific groups of people. Then how do organisms communicate? There's chemical communication, there's all forms of pheromone communication, there's audio communications. If you look at how trees communicate, well, when a fruit is ready to be eaten by an animal, us or any other animal, so that it may disperse its seeds, it changes color, right? A ripe fruit has a different color. So perhaps you can think of color changing materials, maybe the packaging color changes. So there's ways of thinking about sort of innovative solutions. You could be an engineer working on energy efficiency, and you want to use efficient energy. Well, you could look at how do organisms access energy. Leaves use sunlight. There's an amazing little factory on every leaf that is able to convert that sunlight into energy for the plant. So you could think of solar panels as an option. So the point here is that every discipline can learn from nature. I want to mention a couple of other things. One is that there are certain other forms of mimicking nature which are not necessarily biomimicry. Nothing wrong with them, but not necessarily biomimicry. Biomimicry goes a little bit beyond that. So one is biomorphism. So biomorphism is the idea that you can copy what something looks like. This is in Shanghai, what's called the bird's nest. There's also something called bioutilization. This is packaging for wine bottles and made from mushrooms. So it's completely biodegradable packaging, good for the environment, but it's not biomimicry, it's bioutilization. You're utilizing a biological material. And then there's biophilia, bringing nature into your environment. So these are buildings from Milan where they've brought nature into the building itself and created a really sort of good nature home engagement. So these are all forms of learning from nature, but not necessarily biomimicry. So when we think of going beyond anthropocentric design, designing not just for people, but designing for all species on the planet, we start questioning how we do design right now. So a good example is standardization, right? So we build things in mass quantities because it's faster, easier, more efficient, better for the production line, etc. We go with this notion of one size fits all, and that's why there's standardization and modularity, etc. But one size fits all actually really means that nothing fits anyone really well, right? Or fits one person really well. If you look at nature, and back to the desert where I used to live, the Sonoran Desert, if you look at these saguaro cacti, no cactus is identical to another cactus. Like they all are similar in some ways. They have, maybe in a very modular way, they have a central column, they have a taproot, they have surface roots, they have these arms. But depending upon whether it's on one side of the mountain or the other, which determines how much land, how much sunshine it gets, how much water it gets from rainfalls, the cacti are different. So can we use this notion of designing specifically for that landscape, for that location? And so we think of some principles. We can think of maybe going from very standardized way of doing things to more customized, from very rigid designs where once you design something, it is out into the world, it's not changeable, to making things more adaptive as organisms are in ecosystems, from something that's very fixed to something that changes, something that quickly goes obsolete to something that's upgradable, from something that's disposable to something that's repairable. So we could think of several strategies by which we can create designs that go beyond just one solution to something creating that's something that's not just designed for people, but something that's more designed for life. So we could go from a more human-centered design to more life-centered design way of thinking. And organisms, even in death, after they live their life, do something really remarkable. So the saguaro cacti that we've looked at, when they die, obviously they fall. What you see here is a photograph of the structural members of the saguaro cactus. The cactus and all cacti hold enormous amounts of water inside them, right? So, for example, when it rains in the desert, the roots of this cacti are just beneath the surface and they start absorbing water almost immediately. In fact, there are studies that show that the minute it starts raining, new roots start growing. I mean, it's that remarkable of a system. So all the water that's inside this cactus, it starts leaking out when the cactus dies, and that gives more life. So the water actually used by other organisms. So even as this plant is dying, it's giving more life to other organisms. And then what it leaves behind is just a trace, right? So when the plant finally biodegrades and completely disappears, all you see is just a partial history of where that cactus lived. It doesn't leave any toxic waste behind. So I'll wrap it up here. I want to thank all of you for your attention, especially on a Friday evening. Also want to thank all the people at Arizona State University, the Biomimicry Center, Biomimicry Institute, Biomimicry 3.8 folks for the slides, the diagrams, the examples, the images, etc. So I'll pause here, and I think we have some time for questions as well.
Yeah, if anyone has any questions, they can put it in the chat or they can ask them.
Yeah, can I ask?
Yeah, sure.
Yeah. So I wanted to kind of know, like, from you've been dealing with these kinds of like complex, large scale systemic issues for a long time. And what are like the major insights that you've gotten working in this kind of scenarios?
I think most challenges that we face are complex challenges as designers, as people involved in business, as people involved in sustainability or engineering. And what we do very often is we break down our complex challenges or problems into smaller problems. It's a kind of a reductive approach. And then we sort of take these complex challenges, break them down into individual sort of smaller problems, and then tackle those individually. Or another strategy is to create sort of cross-functional teams to take on these complex problems and then solve them from a sort of a transdisciplinary, multidisciplinary perspective. So the way to think about this, and one of the best-known planners of all time, Horst Rittel, talked about problems as wicked problems. And what he has written is that many of the problems that we face today are wicked problems. A wicked problem is one that has no single solution. The problem itself keeps changing over time. The means of solving it requires multiple disciplines to engage simultaneously, et cetera, et cetera. So non-simple problems, non-trivial problems often are wicked problems. And so we have to change our strategies, our methods of doing design. We have to change the way we think about how business operates, how design operates, how engineering operates. We have to recognize that these disciplines work together. And it's only when we work together in cross-functional ways that we can actually take on and address these complex challenges. But it also happens, can't just happen at the level of design, engineering, business, et cetera. It has to happen at a policy level, has to happen at a governmental level, has to happen at an educational level. So I think taking on these sort of complex challenges requires all of us in a variety of disciplines to tackle them together.
Right. I have one more question. Should I ask that, or if somebody else wants to?
You go ahead.
Yeah. So one of the other things I wanted to ask about was that when you've developed like so many interventions and worked on so many issues, have there been scenarios wherein the intervention works, but it just wasn't accepted by people, or faced like that kind of an issue where it didn't fit into the society or the culture it was put out in and failed because of that? And how do you deal with something like that?
Yeah, so that happens very, very frequently. And this actually is an issue that is often not talked about in sustainability. So when we talk about sustainability, typically we talk about social and environmental, right? So social sustainability essentially refers to when we're designing something, does it make sense from a social perspective. Is it manufactured in the correct factory conditions? Is there fair wages for the laborers, etc.? So that's the social side of sustainability. The environmental side, as we talked about, essentially is it non-toxic? Does it lead to extinction, or is it good for the environment, et cetera, et cetera? The aspect that's not talked about, and that's what you're referring to, Anuya, is cultural sustainability. What happens, and this is one example, would be what happens when you design a product and it goes into an environment and a culture that is not used to seeing that before. So it's a brand new product for that specific culture. What happens in that situation? Well, there's one of three things that could happen. One, it is accepted by people and they adjust their behaviors and they have to make do and they have to struggle through and try to use it the way it's given to them. That's one. Second thing, people are extremely creative and they go through this process of indigenization. So they'll take the product, they'll change it, they'll modify it, they'll do something that makes it more meaningful to them and it fits in their lifestyle more. That's the second thing that can happen. The third thing that can happen is total rejection. So these are the three things that could happen when you take something out of context or you design something that may or may not be culturally appropriate to that location. So what companies can and should do is to recognize that these are the three things that potentially could happen. And can we, before we throw this out into the world, can we imagine what could happen? Can we go into this culture, do some research, do ethnographic research, spend some time, really understand how people in this community live, what their lifestyles, attitudes, behaviors, motivations, needs are, and then design with that in mind. And when you do that, you minimize the probability of something like that happening.
Thank you for that. I have a question based on your answer for this one. You mentioned that when we try to design something for a community, it's better if we spend more time in that community and based on ethnographic research, which is generally long and is also time consuming. I just wanted to know if there is a problem which is likely to change over time, and we're spending time on the problem that is currently, but it is bound to change later. How do we think of tackling it in the future?
So everything that we design goes out into the future, right? So if you're working on a problem right now, it takes you time to understand the problem, come up with a solution. It gets produced, manufactured, digitized, et cetera, and goes out into the world. So whenever we design something, we're designing for a future condition. We're never designing for the present. The present is constantly switching into the future, right? It's happening as we speak. So what you can do is, one, recognize that people's needs are dynamic. They are not static needs. So if you go out and do research today, you know your products can go out to the market maybe 6 months down the road. You keep that into account. You have to bring that back to your studio and recognize that these will change. This is a solution that works right now, but I'll have to go back and do additional research continuously. So one way to do that is for you first do what's called foundational research. You go out and you understand people's needs, motivations, attitudes, behaviors, etc. Bring that back to the studio and you start to design process and try to address those needs. You build a few prototypes, you go back out into the world, you test them, you get people's feedback on them. They may have changed by then. You come back and make modifications. When you take the product out with your first production device, you take that out, you do more research. So the idea is that because the present is constantly slipping into the future, you have to constantly go out and do research. Research is not something that you do at the beginning and then you design it and then you're done with it. You have to keep going out in the world. Culture is dynamic, people's needs are dynamic, and products should equally be flexible and dynamic. They cannot be rigid systems that are solidified and unchangeable, but they should constantly change. One of the reasons we have so much problem with obsolescence is that these products that we designed are fixed things, right? They cannot really change. But we are not fixed things. We change, cultures change, we change, our needs change. And so if we design things to be more adaptable, maybe more modular, more changeable, more customizable, then we might be able to, and by doing continuous research, we might be able to sort of design for continuously changing conditions of the future.
Yeah, I think so. Thank you.
You're welcome.
Anuya says that she had lost connection. And
Yeah, I saw the little chat message.
Yeah.
Yeah, I still a couple of messages in the chat.
if anyone has any questions, you can put it in the chat or you can ask them away.
I think it's 8 p.m. and it's dinner time.
We have one question. Would you be able to take that up?
Yes, so the question is, can anthropometric design in some cases be harmful for the environment and creatures? So I'll make one correction. It's not anthropometric, but anthropocentric. So anthropometry is a key part of ergonomics. So anthropometry essentially is you measure humans in order to address your design. So what I'm referring to is not anthropometric, but anthropocentric, which means that we are focused only on humans. So yes, the answer to your question is yes. The reason I'm asking for us to go beyond anthropocentrism is because anthropocentrism is only focused on humans, and so it can be harmful for other creatures and the environment. So this presentation essentially is an answer to your question.
I think that's all the questions that we had.
Excellent.
Can I ask a question too?
No, Manisha is not allowed. Of course, of course.
So just on a parting note, first of all, thank you. But given that many of our products and services, everything is moving digital, how do you see a parallel to what you have been sharing as past 45 minutes?
Yeah, I think we've had some conversations about this in the past. What does sustainability mean in the digital world? So, I mean, a couple of things come to mind. One is, even though we might be focused on a sort of digital environment, every digital experience needs some sort of a physical device, whether it's a phone or a laptop or a large screen or something. So we live in sort of this hybrid physical digital world. And though our emphasis might be, look, I'm a UX designer, so I'm focused on UX experiences, there are certain things that have been done in terms of sort of energy saving. There are conversations these days about minimizing screen time. So thinking of more of the sort of aspects of cultural sustainability and energy consumption might be one way to start thinking about how do we think of sustainability in the digital environment. However, this is still a kind of a bit of a new field. Now, Google has done a ton of work. I mean, Google is a software company, right? And Google has done a ton of work in sustainability. What Google's focused on primarily is, well, Google has hardware as well. And I'm part of the hardware division, so I'm working on some hardware sustainability efforts as well. But what Google has done is looking at where does energy come from for all its data centers. You can imagine how many data centers Google has, right? All these servers that consume tons of energy and tons of water. So Google's focused on energy. All of the energy that Google uses comes from renewable resources, 100%. And that's happened over several years. So by focusing on energy consumption, thinking of where are the environments and communities where these data centers are put, Microsoft is doing this work as well. And what can we do for that community? Can we make sure that we don't affect biodiversity? Can we create jobs for people? So thinking of more, not the specific UX design effort, but more at the level of infrastructure that is responsible and that UX experiences rely on. What can we do at that stage from sustainability? That's been sort of more of the focus right now.
Thank you so much. Yeah, Yumna?
On behalf of NMIMS School of Design, I thank you for your time in introducing us to this part of the art and design industry. We were all intrigued by the new possibilities for anthropocentric design. And as you said, it's important that we go beyond human-centered design to life-centered design. I'd like to ask our director, Professor Manisha Phadke, to say a few words now.
Wow. Well, I don't have to say a few words, but yeah, thank you so much. Yes,
You're
it is
welcome.
Friday evening, but it's also Friday morning for you. But I think coming back to school is always nice. Since now you're Emeritus from ASU. And I really liked the parting shot to do life-centered design. I think as students of design and as mentors of design, I think if we have that as a focal point, we leave the environment around in a better state for the future generations. I think that's some call and some mission we can take up as design students and design faculty, and maybe all of you when you go out into the profession. So thank you again, Prasad, and I hope to see you again sometime soon.
Yes.
And probably we live in our IDC days back again.
Thank you so much. Yeah, thanks for inviting me, and thanks to all the students for attending and the faculty and everyone who was on the call. I couldn't see who all was there, but I'm honored to be invited and happy to be sharing this with you all. So go forth and design. First, enjoy the weekend, and then go forth and design life-centered solutions. Thank you all.
Thank you.
Bye.
Before we wrap up, before we wrap
Oh,
up,
go ahead. Sorry.
we'd like to take a memory. We have a tradition of clicking pictures with a new member here. So I'd like to request everyone to kindly turn the videos on so I'll take a screenshot quickly.